In this video, we're going to talk about acids and bases.
But first, we're going to talk about the properties of an acids and bases. Acids are usually corrosive and they are usually able to react with metals. They also have a sour flavor. An example of this is citric acid, which is what makes lemon sour. They also change the colors of chemical indicators depending on what kind of substance they're in contact with. For example, an acid is gonna turn litmus paper red. And the opposite of acids are bases. A base can neutralize an acid. This one has a bitter taste. For example, when you are taking a bath and you tasted the bitterness of the soap, that means you tasted the bitterness of a base. These are also gonna have a slippery feel. For example, the texture of the soap. And like acids, bases are going to be able to change the color of chemical indicator. For example, a base is going to turn a litmus paper blue. And finally, acids can form aqueous solutions. This means they can be dissolved in water and they can become electrolytes. And electrolytes are substances are gonna conduct electricity when they are dissolved in water. There are three main definitions or theories of acids and bases. The first one is the Arrhenius acid-base definition. The second one is the Bronsted-Lowry definition. And the last one is the Lewis definition. Now, a lot of times you are going to hear this. Hydrogen ions are called proton. And that's because the normal hydrogen atom is going to contain one proton in the nucleus of the atom and then one electron that is orbiting around the outside. Now, when the hydrogen atom becomes an ion, H plus ion here is going to lose an electron. And so it's just a proton in the end. Now, some compounds are going to contain one hydrogen, and so there are only one ion that can be produced. For example, hydrochloric acid, or HCl, just has one hydrogen, and so we can call it monoprotic acid. Mono means one, and then protic is just referring to the proton. And you can see we also have a diprotic and triprotic. It just depends on the number of hydrogens. Whatever kind of acid we are dealing with in the Arrhenius acid and base, the proton here and the hydroxide ion are going to form water. So this is a general reaction that is going to take place when the acid and base neutralize each other. Bases on the other hand are compounds that is going to yield hydroxide ions when they are dissolved into water. Arrhenius explains that acids are compounds that contains hydrogen and therefore they are going to yield hydrogen ions when they are dissolved into water. Bases on the other hand are compounds that is going to yield hydroxide ions when they are dissolved into water. The next definition is called the Bronsted-Lowry theory. These are two scientists that found the problem in the Arrhenius definition. They found out that there are substances that don't contain OH in the hydroxide ion, but will still act like a base. So here's an example. Sodium bicarbonate, or in other words, baking soda, is a base and is able to neutralize acids like vinegar. And so they modified the definition to say that acids are going to be compounds that can donate hydrogen ions, and bases can accept hydrogen ions. In this example, HCl, which is a hydrochloric acid, is going to donate a proton to water. And so HCl is acting like the acid, whereas water is going to act as the base. On the right side, the chloride ion we can say as the conjugate base of HCl. And so that's gonna make the hydronium the conjugate of acid of the H2O. So we can see that when this proton is given over to the water, the HCl will become chloride ion, and this ion is no longer to give away a proton because it doesn't have one anymore. But it could, if we could reverse this arrow and direct it the other way, it could accept a proton from this compound and it could act as a base. And whenever we're looking at a chemical equation like this, there's always gonna be pairs with each other. will have a conjugate acid paired up with conjugate base. It's important to note that conjugate acid by pairs are only gonna differ by one H and the acid of the pair. So these two is only differ by one hydrogen. One final example of Bronsted and Lowry theory is that water can actually react to itself. So here we can see that one molecule acting like a base and the other is acting like an acid. Both substances that can act acids and base are called amphoteric. So the last definition is what we call the Lewis definition. Louis proposed another definition because he found substances that could be acids but doesn't have hydrogens at all. The Lewis definition says that acid is going to accept a pair of electrons, and then the definition of base is going to donate a pair of electrons. So here's an example. Aluminum chloride can react with a single chloride ion to form into a new compound, and the chloride ion, because it has a negative charge, meaning it has an extra pair of electron. The aluminum chloride would actually be able to accept that extra pair of electrons. So let's take a quick recap. The Arrhenius definition says that acids yield hydrogen ions and base yields. So let's take a quick recap. Arrhenius definition says that acid yields hydrogen ions while base yields hydroxide ions. On the other hand, Bronsted-Lowry definition says that acid donates hydrogen while base accepts hydrogen. Then, Lewis definition says that acid accepts electrons while base donates electrons. And that's acids and bases.